there are these other websites. I mean, the most famous one is thispersondoesnotexist.com. And we basically reused their method, the style GANs, to create Earth observation data. And in fact, what I found out later, there's even an entire list. It's called thisx.doesnotexist.com with all imaginable artificially generated images. And yeah, so we basically made it in the same style as these sites and created artificial remote sensing images.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Ron Hagensieker. Ron is the CEO and founder of a company called Adversarial, and on the off chance that I have mispronounced either Ron's name or the name of his company, you'll be able to find it in the show notes of this episode. And today on the podcast, we're talking about artificially generated satellite imagery. So what you're about to listen to is the result of roughly 20 hours of work, none of which would have been possible without the people that support this podcast on Patreon, or the companies which have chosen to sponsor the Mapscaping website. Because at the end of the day, no matter how much I enjoy doing this, if I can't find a way of making this podcast sustainable, then I simply can't keep doing this podcast. So I've given myself a deadline. So by the end of the year, I need to have some sort of sustainable business model around this podcast. I need to be able to cover my costs. I need the cost of my time as well. And if I can't do that, well, maybe I have to do something else. So this is not in any way a threat. And this is not a complaint either. This is, and I'm not even sure if this is a problem or a reality. So when you think about problems and realities, gravity is not a problem. It's a reality. I can't change it. It's not a problem to be solved. It's the way things are. So I'll be working really hard to make this podcast sustainable over the course of the rest of this year. I guess it'll be interesting to see what the answer to that is. Is this a problem that I can solve? Or is it just the reality? I'll keep you up to date on that and let you know how I'm doing with that from time to time. Okay, let's get into the episode. Hi Ron, welcome to the podcast. This episode is going to be a little bit different today. Today we're going to talk about artificial image generation. So we're not talking about capturing images, we're talking about generating them today. And yeah, I'm super excited because this idea of fake satellite imagery, I find it absolutely fascinating. Before we get into the topic, can you just introduce yourself to the audience, please? Perhaps let us know who you are, where you're working at the moment, and how you got involved in geospatial.
Yeah, sure. Hi, Daniel. My name is Ron, as you mentioned. I'm the founder and CEO of Serio, a small company specialized in AI and Earth observation. My background is that of a geographer. I found an indirect way into remote sensing while in my studies for my bachelor's for geography, where I got more and more interested in, data-heavy topics. Originally, it was like geomarketing and data mining. And then the way in Germany, basically, because it's so split, the social sciences and the more physical sciences, I just naturally via the methods found the way into remote sensing, which I followed. In the end, I did my PhD on deforestation in the Amazon, did a lot of land cover mapping and all these conventional topics, but got also more and more interested over the years into, as we will talk later, experimental applications.
So you mentioned geomarketing there. Could you just explain to me what that is? What is geomarketing for you?
Geomarketing, okay. Now, this was more than 10 years back, a small seminar study, right? It was just about, segmenting customers, clients, etc. Has nothing to do with remote sensing at all. But there were these methods like clustering, k-means, and all these, old school data mining methods. And this was interesting to me. And following with remote sensing, it's like a straight line of classifiers, etc., going towards neural networks and generative methods in the end.
Wow, so that's an interesting way of describing it, like a straight line from these classical methods moving towards artificial intelligence and something called generative adversarial networks, which is what we're going to be talking about in just a second. The way I found you, or the way we connected, was I came across a website, and this website is called thiscitydoesnotexist.com. And not very much information there if the listeners go to this link. But what you see is every time you refresh the page, you get a new fake satellite image. Would you mind telling me all about this particular project, and then perhaps we can move on and talk about how you created it?
So first of all, I was surprised to see people still referencing this website. It's something my friend Thomas Langer and I did like nearly 2 years ago, I think. there are these other websites. I mean, the most famous one is thispersondoesnotexist.com. And we basically reused their method, the style GANs, to create Earth observation data. And in fact, what I found out later, there's even an entire list. It's called thisxdoesnotexist.com with all imaginable artificially generated images. And yeah, so we basically made it in the same style as these sites and created artificial remote sensing images. So a couple of weeks ago, you found the website. And now, even though it has been like a more or less dead project for a while, I'm happy to talk about it again.
Okay, so you used some sort of artificial intelligence method to generate satellite imagery. What is this method? I know from a previous conversation you've mentioned something called this generative adversarial network. Is that what you're using to create these images that I'm seeing at this website?
To make it a bit more detailed, on the website, you can find on the very bottom, there's a poster linked. And this poster goes into, at least on a high level, a bit more detail into what we are doing on the website, but also at this point, what else we have done. So we use, for example, the style GAN, but as well the predecessor, the progressive GAN. And we use these methods to create these images. We didn't only create city images, but as you can see in the poster, there are also like DEMs that we can create. It's a lot of highly specified, highly specialized generators, which serve to create different types of imagery data. The data we create is Sentinel-2 in the case of the city-does-not-exist.com website, but we also used other data sources.
So I think you used the acronym GANT a few times there. What is GANT?
No, GAN. Basically, it's these generative methods. They consist of two neural networks, right? There's a concept called adversarial, and basically there's one generator and one discriminator network. The discriminator serves the simple purpose of determining what is a fake image and what is a real image. And this is trained. And on the other hand, you have like this generative network, which just receives some, let's for the sake of simplicity, it just receives some random noise as input, sampled from some Gaussian distribution. It just creates in the beginning some gibberish image. But this is trained, in fact, as well, in order to reduce the accuracy of this other one, the discriminator. And in their interaction, you basically have the generator, which gets better and better in generating images to fool the discriminator. And yeah, the discriminator as well becomes better in discriminating between real and fake. And ideally, if this is all well balanced, the training is a bit tricky. And the methods, like I said, it's just a high level explanation. The methods have a lot of, additional components. But then if you achieve a robust training, you can create images which look fairly okay. I mean, as a human, you can still make out the difference, but it's at least, aesthetically a bit like a real image.
Just so I understand this, it sounds like we have these two neural networks and they're almost in competition with each other. One's generating and the other one's testing to see if it can identify the fake images. Does this mean that you have effectively built in a positive feedback loop? So as the generator gets better, the other piece of the network also has to get better at discovering or identifying the fake images. And can this just sort of go on and on into infinity?
It can. At one point, it converges depending on, complexity of the network, and especially also it's limited by the amount of input data. But in the end, if you organize your training right, these things become, let's say, better and better. Also, I have to say it is pretty computationally heavy. Like I said, we used thousands of remote sensing images. There are some limitations. Remote sensing has two components, basically, which make it on one hand interesting and on one hand challenging to do this. I mean, from a very naive standpoint. The one is, as I assume most of your audience is aware, these satellite images have a very big extent. They are oftentimes like 10,000 by 40,000 pixels or something. This would kill any memory. The images we produce, they are like small chunks. I think the maximum sizes we did was like 1024 by 1024. And also mostly just like 3 or 4 channels, right? Just because otherwise you run into memory limitations. I mean, we did this on a small scale as a fun side project without big financial backing. So this is the one challenging part with regard to EO. The inviting part, and I, I guess this will be a question you also will want to ask. The inviting part is it's more or less unsupervised. We can also talk about supervising it, but it can be the way we did for this website. The only supervision is basically choosing the locations of cities, right? And then you just extracted via OpenStreetMap data all the cities, all the city centers, and made a small frame around it and extracted all the data. And then we naively just threw it in to train. And we didn't need any annotated data, any expert knowledge. It's just a very data driven, let's say, simple approach. There's no big interaction or manual labor needed.
Well, that's a really interesting approach. Like, that's a great idea using OpenStreetMap in that way, finding the city centers, creating a bounding box, and using that as a cookie cutter, I guess, in this case, against a database of Sentinel-2 imagery. You mentioned early on in the conversation that you could use other things. I think you talked about elevation. In theory, can I add as many channels as I want to this? So RGB, the visual component, could we put elevation on top of that? Could we create a population layer as long as in a raster format? Can we put an unlimited number of channels into this kind of process?
Yes, limited by memory in the end, right? It could also be nice to do it independently because there could be cross correlations between layers. It might depend on what one wants to achieve. It might have a positive or a negative effect. But generally, it's all as soon as the layers are well co-registered. I mean, but that's a given. As long as it's not limited to 3 channels or something.
So we've talked about using raster data images in this generative adversarial network. What about vector data? Is it also possible to use that in this process?
Yes, in fact, I've been thinking on it for a while because what I also mentioned is that a lot of times people are more interested in deriving information from the raster data. Especially urban data comes in vector form. And a lot of times this has some graph structure, right? So you have road networks, you have all kinds of network type vector/graph information. And one more exotic thought I was having in the past, I never got into experimenting with it, is these generative methods are used a lot, for example, also in medicine to create new, molecules and medicine. And yeah, the data source here is the same, right? Just as you can transfer the method from creating cat images to city images, you might as well, with few adaptations, create a graph network from a road network and throw it into a similar generative network. And it might lead potentially, depending on how you condition it, etc. It might make a more efficient city planning concepts. These could be potential outputs, but it's something which has just been one time flying around in my head once, but it could also be interesting.
So I understand that this is an idea that you perhaps haven't tested out. It's just a thought that you have, like that this is a potential outcome of this. Is what you're saying that you could potentially use these generative methods to throw on a road network and produce a lot of different other kinds of road networks, and then perhaps use them in modeling systems. What is the most efficient road network given this kind of environment? Is that the kind of thing you could imagine this being used for?
Yeah. Especially, you can fill it with a lot of layers, including EO data or raster data, etc. But in the end, what the generative process would be about is creating a graph data set with these other information layers as this conditioning part. You could have a DEM also in there. I mean, you are free to put everything. I mean, computationally wise, it might be limited again by the memory, but you can as well. You're not limited to creating images, right? It would be different types. You obviously wouldn't use a style GAN, but there will be highly specific methods from this part of generative AI. And you can create, let's say, geospatial data, vector data as well with it.
That is really interesting. I appreciate you for sharing that thought with us.
I mean, for me, as someone who does it more for the experimental purpose, just the idea alone of applying methods that have been developed in some chemistry context to just a totally separate field, and in the end, it might even work. This is just fascinating.
But when you're talking about correlation, I'm sure in our pre-interview you showed me this example of population.
Mhm.
Do you think you could walk us through what was happening in that example?
Basically, we did another. So the city does not exist was one instance of the fun work with GANs we did. Basically, we did it without, yeah, we did it with fun, but without funding. We basically had just the idea of, as I said, we can easily extract a lot of EO data and make some images with it. And we did another project afterwards where we were also lucky it was in the end published in Europe's Climate Change, where we created a more interactive approach. Maybe you can link it on the website. There we have a collab also where everyone can click around, which is based on this concept called conditioning. And for the conditioning, it is possible to regard layers also as a given input, as a conditional input. And then these generative methods learn based on a particular layer how these structures look. So we took from the JRC, there's this famous, I forgot the exact name, a global population density map, which has, I think, a resolution of a square kilometer. And you see how many people live per cell or something. It's also EO based and there's some errors in it, but for our purpose, it was sufficient. So we used basically this to learn, let's say, the image patterns of population density. And in the end, Thomas, my partner, did all the heavy lifting there. In the end, he did a nice tool to basically draw. You draw the population density, and then you click a button, and you create an image. And it also figures out reasonably how it looks, right? It's not just where you put the brush, but it will fill the gaps as well and make a very reasonably looking, I now forgot if we took Landsat or Sentinel data, image of Central America. We did for the Mexico.
So what I noticed about this example when you were showing me how it worked was that, so it was the population that decided what the image ended up looking like. And it was absolutely amazing. So things that stuck out for me was as the population increased, it created larger, more sprawling urban areas, more dense in some places. It also created more agricultural land around the urban areas. There didn't seem to be any discrete edges. And you also had this great example where you created two separate urban areas, two separate population densities. And as you increase the size of those densities, the urban area that was generated in the image sort of grew naturally together. It emerged in a really sort of natural way. It was absolutely amazing.
Yes, that's the most impressive. I think if you play around a bit with it and you develop a bit of a feeling, it's very nice to see, especially not just the areas that you draw, but especially the reasoning that the thing does. That's, I think, also the most interesting part.
Okay, so now this was super interesting, absolutely fascinating work. What can people do with this? Why would anyone build this? What can they do with the result of this kind of work?
Yeah, we wondered about this as well. So in the end, it was a bit like I said, it was not, we didn't put too much thought into it. We just did it because we could. You can now have an ethical debate on this. It was a fun side project. But after that, obviously, we, like you, people see it, people are very fascinated by it. And I think on first glance, they have a lot of ideas for applications. But on second thought, it's sometimes not so easy to find something tangible because mostly analysts or decision makers, they are interested, they want the opposite, right? They want the analytics product. They want not an image, they want some abstracted KPIs or something. And what we are doing in a way is we create the raw data that is mostly for the real world, it's the starting point. And then it's like a loop. So from a technical, the most obvious thing, which has also recently been argued in literature, is to use such data to augment like training data, to bloat data sets, where there's also a lot of discussion whether this really leads to additional information or if it's just redundancy. I don't have a standpoint on that. From a technical point, this is the most obvious use case. From a standpoint of using this for, city planning or something, this is challenging. I mean, I'm from Germany. I didn't mention in the introduction, but in a country like Germany, everything is very well planned. There are rarely any of such dynamics which you might want to model in a way. Maybe for modeling deforestation patterns, these fishbone structures, or in urban settings, if you have a developing country where there's less formality in the growth process of cities, maybe this could be interesting. But it's really hard to point a finger.
Would it make any sense at all to use this as an interpolating method for missing data in imagery?
Yes, that's the other I forgot to mention. So research shows a lot of cases where such things are used for, cloud masking, filling the gaps. Also, in other computer vision disciplines, such methods are used to fill the gaps, which can be argued, I think. such things also need, in fact, a lot of validation to make it really cleanly, because when you just, it's a bit like I said before, if people are interested in the analytics, let's say you do a crop classification and then you just fill in the cloud, it will often, it might be easier to just do it with the analytics product, right? To fill in reasonable image data is, I think, oftentimes a bit overkill. It might lead to harmonious data, which is nice, but the real additional meaning and also its validation, also considering that there are time series. So we only always work on single imagery, right? But if you would extend the methods to include time series information, etc., I think there is where the, let's say, the real application value would come. But this does not exist out of the box.
Okay, so we've talked about a few potential sort of real world examples, how this might be useful in the real world, solving problems in a positive way. I have to admit, when I first saw this, I was like, wow, this is another example of fake news, of deep fakes. I can't believe people were doing this. I was kind of shocked. And part of me was shocked because at first glance, it wasn't immediately obvious to me that this was a generated image, that it wasn't a real satellite image. I wonder if you could take the time to help us understand what we should be looking for. Are there any sort of artifacts in these images that we could use to identify them as being generated images?
I mostly speak for myself and for the things we did. So, I mean, the very most obvious observation is that, and it dominates every. So, I think where you can directly see that it's fake, at least for what we produced, is that the roads are generally not very straight. My partner Thomas has much more qualified opinions on why this happens. For example, such methods are oftentimes, I mean, the original ProGAN and StyleGAN have been developed to create faces, which also lack straight structures. So this is the most obvious one. You will see that no matter how good the training, generally there are these a bit blurry looking structures, while what humans do is oftentimes very, very cornered. Yeah, this is the obvious one. There are these false friends. This city does not exist has been reposted in some areas, and then people discuss in message boards how bad it works and stuff. And one false friend is obviously we didn't do any big processing on the EO data, right? Everyone who works with EO knows that there's the blue haze, the atmospheric effects, etc. They are all present in the data. So people might argue something like, "Oh, look, it has a strange shade or something." No, these things are real artifacts, which exists in such type of data. The real pointer is, like I just said, something like curvy roads.
It's interesting. So I'm looking at an image right now, and I thought a lot of what you were talking about was just a result of the resolution of the image. I thought, okay, the pixels are so big that things are blurring together, and some of these lines are being a little bit distorted, and some of the urban areas just look a little bit faded.
Hmm. Yeah. Also, the resolution seems a bit lower, I find. I didn't mention earlier, sorry to make a jump, another application area. So there's a big topic, I guess also everyone is aware of, is the super resolution. This similar methods are used excessively to achieve this. I just want to mention it. Pixels appear blurry and downscaled, which might be based on this property that these progressive GAN-based methods have. You're totally right, yeah.
Could you just go back to that example you were talking about with super resolution? I'm not quite sure I understood how super resolution would fit into this concept, or how image generation would be useful in the super resolution process.
Yeah, the methods are a bit similar. I mean, you can just understand it as what you generate here is the information on a sub-pixel level, right? You feed into the network an existing lower resolution image, and you have obviously trained via higher resolution reference data something with a higher resolution. And then what these generative methods create is like higher resolution pixels based on the correlations of the existing data sets of varying resolution. Was this clear enough?
Yeah, I think so. So it sounded like you said on one side of the algorithm, again, if we divide it up in two, we have lower resolution pixels, and we say, please, this is what we have, but it needs to look like that. So maybe you'll take a high resolution image and downgrade it and say, okay, this downgraded image, make it look like that high resolution image. And if it gets it right, then it's acceptable. Then the algorithm has succeeded. Am I on the right path?
Yes. Ideally, you have like two different sensors or something, one with a high resolution and one with a lower resolution. Then you train the lower resolution generative process to achieve images which resemble the higher resolution one. And in the end, if you have this model, ideally you can ignore all the high resolution data and you directly upgrade your lower resolution data. I mean, there are a lot of discussions about accuracy and false correlations there and whatever might go wrong, but this is technically how the approach would look like.
That is really interesting, and that is a great example. Thanks very much for that. I appreciate that. So I want to stick with this idea of deepfakes and fake news. I think over the last few weeks, with the recent outbreak of war in Ukraine, we've realized how quickly media spreads. It spreads really fast, and we can't put the genie back in the bottle. We've seen some pretty horrific scenes in terms of wildfires, and I want to use wildfires as a bit of an example to help sort of people understand how perhaps we could connect this idea of media, deepfakes, and a natural disaster. So I'm wondering if I had lots of scenes of wildfires, so with a very obvious particular feature in them, like a wildfire, could I create a bunch of fake imagery that also had wildfires in it? Would that be the result?
Yes, you can definitely. There are these. I mean, there's this concept called style transfer, and images are being merged and blended, and components of one image get overlaid into another, and it all looks very scarily realistic. I'm not talking about EO. There might be papers on that, could be, but in just changing the color of a car or doing this thing. In EO, I saw it basically with changing the season. You have a summer image, and then you put snow on it. You could as well, put smoke into it. This all can be done if you have a good data set. I think this is always the condition, and then you can do a lot of these shady things. Let's call it like this. On the other hand, I feel first when people talked about exactly this, like they saw you can create these artificial cityscapes. You talk to people about it, and I mean, it's not EO people. It's generally like the average person who's not in contact with such data. He will find it scary in a way. I think the reaction of a EO expert is like, yeah, obviously I know the source of the data. I directly see everything that's wrong there. But when you mentioned this genie, put back the genie in the bottle, that's the thing, right? You can easily distribute these fake looking images and they develop a story on their own. And before anything gets corrected, you just don't get the real version out. And in the meantime, everyone uses an image in the way they want. Yet, regarding generative methods, I feel the way, least effort way, is to just take images out of context. I think a lot of just the basic reflection on where an image is taken at one point, it's not there. If you publish it as a JPEG on some website, in some newspaper article, totally out of context, a real image, there's already a lot of danger in it, right?
Yeah, I think that's a really good point. That if we think about this as a threat, then obviously the threat is already here, because any image we take out of context can be used in a manner that it wasn't intended to be used in. We don't necessarily have to be talking about Earth observation imagery, and we definitely don't need to create or generate images via these methods that we're talking about in order to do these kinds of devious things. I think that was your point.
Yes, I just saw it recently just because of Ukraine. I mean, it's the elephant in the room, right? My LinkedIn feed is full of satellite images from Ukraine, and the topic of open source intelligence gets thrown around a lot. But in the end, what does open source mean? The acquisition process is a bit selective. These images don't get constantly acquired by the sensors, they are more or less ordered. Then images are published also selectively, and it's not like there's a very free, transparent archive of images. I mean, aside from the lower resolution ones by ESA and NASA, but for the very high ones, there's just from the point of distribution already, there's a lot of things where one needs to, step a bit back and think of, oh, is this really based on an unbiased, speaking as a scientist, of an unbiased sample of all the images which might have been acquired? There's always these tendencies. And these tendencies, now that we're here, it is hard to train a generative method because you need so much data, obviously, on these proprietary data sets, right? If one would want to do something controversial with very high resolution data, one would need a lot of, let's say, controversial input, because the AI is generally also not magic. It will require a lot of this material with this certain property. And I think at this point already would be a blocker for, let's say the average bored EO scientist to make a fun story. Because there you need real intention, potentially real money to achieve something, I think.
Right at the start of the conversation, you talked about this algorithm, this method consisting of two separate neural networks in competition with each other. The side of the algorithm, that neural network that is trying to decide whether an image is fake or not, could we take something like that and use it to detect fake imagery elsewhere? Would it work in combination with any sort of image source, or does it have to be from the image source coming from the generative side of the algorithm? Does that make sense?
Yeah, there's a lot of discussion in AI overall about this concept of transferability. And it shows that, in fact, a lot of things are easily transferable in a way, but they still always will need some form of adaptation. I mean, it's just something where you could also have multiple detectors, based on the different sensors which exist, which have all been trained on a variety of potential fakes. This is definitely realistic. It's just that it's also something that cannot be achieved out of the box very easily. It just would require a lot of man hours put into it. But this is something which I think as well would be highly useful. I mean, also, if you have now all these investigative data driven journalists, this could be a very relevant tool to develop, I think, to ensure the integrity of the imagery.
So I think it's time in the conversation now to look out into the future and ask the question, well, where is this kind of stuff going? We talked a little bit about some of the practical applications for this. And you were saying that it was hard to find practical applications. And I guess when we look out into the future, will those constraints go away in terms of finding practical applications for this based on increased availability of data, increased processing power, all those kinds of things that we've come to expect with technology? Will they make this kind of thing so good that we will start to see more and more practical applications for generating these kinds of images?
Oh, that's a very good question. To be honest, I'm not entirely sure for the same reasons I mentioned earlier. I can easily think of, and maybe it's already in place and I'm just not aware of, that these, what you call practical applicability, that this is something which is technically already been done, to enhance data sets, etc. This one practical use case I mentioned. For real, let's say, modeling, etc. applications, I'm not entirely sure. I didn't investigate it so much, the use cases. If there's something which is very obvious to someone, I would be super interested to discuss it in the future. But at this point, I really like to see something really tangible. And I don't mean to sound pessimist. It's just that there's really this big effort attached to training these methods. And I mean, what we did also was this very undirected generation of images, right? As soon as you create a certain environment, like for super resolution and for other methods, yes, there definitely are and seem to be application areas. But regarding this just, image generation, more or less from scratch for like the sake of art or whatever you might want to call it, I think there are some exotic cases. I think Benjo was it, one of the I think it was him, fathers, he talked about using this for communication, basically for making people more sensitive, not with regard to EO, but if you see how your house is flooded in a photo, you might become more aware of not building next to a river, something like this. Things like this can and have been done by this FDL, for example. This is something which could be. And there's one more topic I like to bring up, because this entire concept of adversarial networks, etc. There's obviously also this other component of fooling networks in, let's say, in reality. Maybe you've also seen these examples of people avoiding face detection by placing interesting patterns on their glasses. Or there was a very interesting one by Google where they use a specifically shaped object on a street which becomes invisible for the car's lidar. So these are obviously also things from the, let's say, adversarial neural network scene, which could in the long run become relevant in EO, right? With regard to, let's say, insurance fraud. This is the most blatant one. Or other, I mean, I don't even want to open the can of military applications, but you might want to hide things which are based on some automated L-based extraction process. And this is also one realm of adversarial networks.
Okay, so what you're saying here is this adversarial network could figure out the blind spots in another algorithm, which is super interesting in a time where we are creating way more information, especially when we think about Earth observation data, than a human could ever look at. There's so much coming down from space on a daily basis. The vast majority of it will never be seen by human eyes. So it's algorithms that are looking at that. And so in your example there, adversarial networks will become more interesting because they will figure out the blind spots in these other algorithms. At least that's what I'm hearing you say.
Yes, you hit it on the head. It's basically exactly that. I don't want to call it the problem, but algorithms are put on satellites, right? I mean, in the ideal case, you get rid of the data before any human sees it. For latency reasons, you do the on-edge land cover mapping in space. You only send down the analytics product, and you totally rely on the ML algorithm. And there already the problem starts. It will be very hard in the future. I'm now talking some sci-fi scenario here, but it will be very hard to point a finger at where did something go wrong if basically the data amounts that are gathered on edge are so big that they are not communicated anymore, and you totally rely on the ML. And if this ML can be fooled, then the fun starts.
So objects, features in the landscape would essentially be invisible.
Something like this. This is sci-fi what I'm talking about, but because you mentioned this fewer and fewer, I mean, in comparison, I would say if you would have a graph of like the percentage of EO data that human eye looks on, it will become lower and lower. On the other hand, the amount of data that is generated overall, it will become bigger and bigger. So in the end, it's just a super small fraction where there's any, sanity checking done by a human on the data. And so the dependence on the ML to work in a robust way, so there's this whole topic called robustness and trustworthiness, is a very big one. And there's definitely some papers from other domains which look into this, which are, might find applications in EO.
Well, Ron, you've given us a lot to think about, and I really appreciate your time. I think you've done a brilliant job of slowly and surely walking us through this topic from end to end. Thank you so much for that. Really appreciate it. I'm sure there's a bunch of people out there that are listening to this and thinking, wow, how can I carry on this conversation? How can I reach out to Ron? I know that's the case. How can these people do that? Where can they go to connect with you?
Yes, sure. First, let me again thank Thomas Lange, my colleague with whom I've been doing most of this. I'm not so present at social media overall. You can find via my name me on LinkedIn. You can also, I would be super happy if you drop a mail, ron@osir.io. On the other hand, yeah, the easiest would be just go on this citydoesnotexist.com website. On the bottom, you will find this poster. You will find contact info there. And also, Daniel, it would be nice if you can link this Colab notebook, because I think this is the most fun thing to play with overall.
Yeah, I definitely will. I'll gather those links off you, and they'll be available to the listeners in the show notes of this podcast episode.
Great.
Thanks again for your time, Ron. It was great talking with you.
Thank you too. Thanks a lot.
So I really hope you enjoyed that episode with Ron. As always, there will be a bunch of links in the show notes of this episode to help you catch up with Ron, to connect with him. I'll be linking out to This City Does Not Exist, and also the other website that Ron mentioned, This X Does Not Exist. So this is a collection of some really interesting examples of fake imagery. As Ron mentioned during the episode, the most famous of this is probably This Person Does Not Exist. It's well worth going along to this website and checking it out and just seeing what is possible and how far these algorithms have come. So during the conversation, Ron mentioned a few topics that we've covered before in the podcast. One of them was super resolution. If that's something you're interested in and haven't yet heard that episode, go scroll back through your podcast player and look for an episode called Super Resolution Smarter Upsampling. Ron also talked about open source intelligence. So this is, of course, particularly interesting given the war in Ukraine at the moment and some of the information we're seeing coming out of that. And if that's something you would like to know more about, there's an episode called The Role of Geospatial in Open Source Intelligence. And I think that's well worth checking out. So right at the start of this episode, I mentioned that I've given myself a year now, or to the end of this year, to try and make this podcast sustainable. If you want to help with that, if you want to be part of that, firstly, I'd really appreciate it. And secondly, the place to go is mapscaping.com. There'll be a link to where you can support this podcast on Patreon. And if you're a business or organization, there'll be a little bit more information about how you can support the Mapscaping website. And if you're sitting out there with a great idea about how I can make this podcast sustainable, I would love to hear from you. just reach out to me on Twitter. You can find me at Mapscaping, and there'll also be links to my LinkedIn profile in the show notes of this episode, or just go to mapscaping.com. There's email addresses there, there's contact forms. You can get a hold of me there. I'd really appreciate some help with this. Okay, thanks very much for listening all the way to the end. I really appreciate it. I'll see you again next week. Bye.